In this problem, we're considering a reaction that is a zeroth order reaction, which means that it's going to follow this integrated rate law that's given up here at the top. Now, we're told that the reactant at beginning of the reaction has a concentration of 0.84 molar, and we are asked what will its concentration be after 24 minutes if its rate constant is equal to this number, 0.025 molar per minute. Now, it's important to keep track of these various units because with this with this unit for the rate constant, we're going to naturally expect the time to be expressed in units. So we need to be wary if it's expressed in hours or seconds. So how would we do this? Well, the thing that we're looking for is the concentration of the reactant, which is this quantity in the integrated rate law. So that's the thing we want to solve for. And this notation means the concentration at the time t. In this case, the time t is 24 minutes. So we're going to be using this as the initial concentration, which is 0.84 molar, minus the rate constant, which is 0.025 molar per minute, times the time, which is 24 minutes. Now here's a point at which you want to check the units. Minutes here would cancel. I would have this in units of molarity and this in units of molarity, so that's consistent. This will end up being 0.84 molar minus 0.60 molar, so the final result would be 0.24 molar for this part of the problem. So that would be the concentration after 24 minutes. Now in the second part, we're asked how long will it take for the concentration to be reduced to this value. So this now is the value of our reactant at some time t, but we don't know what the t is. That's what we need to solve for. So when we set this up into the integrated rate law, we would have 0.40 molar, which is our concentration at time t, is equal to our initial concentration, which is 0.84 molar, minus K, which is 0.025 molar per minute, times time. Okay, so this is our initial concentration, and this is K. All right, so that's how this fits in the integrated rate law. Now, in order to solve this, we'll need to rearrange this a little bit, so we'll subtract 0.4 from both sides, and that will give us 0 is equal to 0.44 molar minus 0.025 t molar per minute. Okay, when we rearrange this, we'll bring this over to the other side, which by adding this amount to both sides. And then we'll divide through by this coefficient. So in other words, if I have 0.025 t is equal to 0.44 molar, then I'll need to divide by this amount to solve for t. Okay, and remember this is in units of molar per minute. So when I do this, I'll have t is equal to 0.44 molar divided by 0.025 molar per minute. And since this is in the denominator of the denominator, it becomes the numerator. And when I do this division, I find that this turns out to be 17.6 minutes, which will be the answer to the second part of the problem.